Aye.
Any opposed? Checks to the treasurer? No, okay. All right, that's our new slave law. All right, so let's get on to the fun part. So we have I'm so sorry. That's okay.
Well, he's all the way across the room from
So we actually have a speaker today, Quentin Morse, who's a attorney from North Carolina, but has land in Virginia, where he's doing chestnut research, and he's going to talk to us about a way of testing chestnut leaves to see if they have resistance to specifically to oxalic acid, which the blight produces as one of its methods of killing the tree or using the tree at the. And so he and Jared Quisenberry helped this pretty interesting and useful test, and he's going to tell us a little bit about it.
Sounds good. So I guess do I need to sit here? Is it going on?
It is broken. So
Okay, wonderful.
we can hear you though.
Great. I like standing rather than sitting. So hello, everyone. My name is Clint Morse. As John said, I'm an attorney in Greensboro, North Carolina. And a year ago today, I would have never believed that I would be telling you about an improved oxalic acid leaf assay using dose response linear regressions. I met Jared a couple of years ago on Facebook through the ESF Darling Facebook group that has tons of members. Jared and I are roughly the same age. Both of us have obviously liked chestnuts quite a bit for quite a long time. And I know Jared became really enthusiastic about it. He lives around here, and he was out hunting and he found a pretty large tree on his property and went, "This is pretty interesting." And so then he went into the Darling rabbit hole as well, started planting some trees, waiting for them to be pollinated. Again, that's where I met him, was through that exercise. We would find nuts, exchange nuts with each other, grow out a couple of trees, believing that we would eventually be crossing them with the transgenic pollen. And that's what we were doing. I am obviously a lawyer in Greensboro, North Carolina. We bought some property in Grayson County about 6 years ago. Obviously, everything in Western North Carolina, Southwest Virginia was hurt really bad. And so I've always, anytime I'm talking, I always want to remind people, know that's going on. It's not part of the news cycle anymore, but anything we can do, it still is a major problem. This house here is actually where I got interested in chestnuts. So these are my neighbors in Grayson County, and luckily for them, the floodwaters receded right before it hit the house. But they were redoing their kitchen, and they had a bunch of chestnut wood from an old barn, and they did their cabinets with the old chestnut wood. And started talking to them about it, and then Googled and saw the whole Darling items that were going on. And so that's how I got into Darling and getting ready for the transgenetics. And that's what we were doing. We were planting chestnuts on the hillside you see over there. Is the background is my property, and that's got about 10 just American chestnuts that we were intending to cross with the Darling transgenic pollen. So come last fall, obviously, there were some significant problems with what our plan was for the Darling exercise. And I'm an attorney, Jared's an optometrist. Neither of us are research scientists, neither of us work for a research institution, but we don't sleep very much and we read a lot. So, and we have a lot of enthusiasm. And so we started talking and we started reading, and we went, and finally in January last year, I woke up at like 2 a.m. and went, okay, what Darling was trying to do was create a tree that was oxalic acid resistance. You can't, and at that time, we'll put a little pin in this, I believe that it would be impossible to breed Americans to blight resistance because blight would uniformly kill the trees. But I had this just light bulb go off and went, there's no reason why you can't develop a protocol to test the Americans for oxalic acid resistance. And if you did that, eventually, if the Darling theory is right, you would have a blight resistant tree. So that's what we began this project based on. We believe that we could develop a protocol that would allow you to test Americans for oxalic acid resistance. And why would we want to do this? Well, we do believe 100% that all effort to restore the Americans is complementary. Jared and I believe, could be totally wrong, but we believe that you can breed Americans to blight resistance. But let's say we're wrong. If we're wrong, improving the American genetics will still help all the other programs, the hybrid program, the transgenic program, whatever ultimately works. It will work better if we have better genes for the Americans. So we figured, let's go try this. Let's figure out how this works. And when I started Googling, which is an amazing tool, we have amazing tools in Google and AI and everything else now to help you research. It brought me to the Ozark Chinkapin Foundation. And the Ozark Chinkapin, for those that don't know, is a cousin of the American. And the Ozark Chinkapin Foundation is in Missouri. And they've been running oxalic acid leaf assays for a while to screen trees they find in the wild to enter their breeding program. And so I contacted the Ozark Chinkapin Foundation, who also put me in contact with ESF, who helped them develop this leaf assay that they do. And the original idea that what they did is they used 6 16-millimeter discs, and they soaked it in 50 micromole oxalic acid, and then measured the necrotic area of the disc after 24 hours. And we spent a lot of time figuring out how to actually do that. And this is the results that you get from these types of tests. And we actually spent quite a bit of time figuring out how to get discs that look this clean, that have very clear delineations. That took months to be able to get to a point where you could consistently get leaf discs like this. And we are psyched. We are sitting here going, we've got this protocol down. We're going to be able to go and run these tests on these trees, and we're going to be able to get results that either are going to confirm or deny our hypothesis. So this slide is a little messed up, but we go to Lacine and we meet John, and we take leaves from a bunch of the LSAs there. And we also have trees from just blighted stump sprouts. And we start running our tests. And what you can't tell here is that the leaves here on the right-hand side of the screen, these were 50% dead, necrotic. And the leaves on the left-hand side of the screen, my left-hand side of the screen, these were 47% necrotic. Now, if our hypothesis is right, and the death percentage based on oxalic acid should correlate to blight resistance, or have some correlation, which tree would you expect to perform better in the field? Tree on the right, or tree on the right that had more necrotic area, thus more death from oxalic acid, or the tree on the left? I'll kick it to the one on the left. That was not the expected result. Tree on the right is Thompson. Tree on the left was the quickly dying stump sprout. So that got us to a point of going, either we're totally wrong, and the Ozark Chinkapin Foundation is totally wrong, or there's something that's a little messed up in our protocol and our test, or not just a little messed up, but really messed up if that's the result that we're getting. And we thought about it, and we went, leaves are going to have different absorption and different transpiration rates based on the environment of which they live. And we tested this, and we ran a leaf assay at room temperature and a leaf assay in the refrigerator. So the room temperature having normal transpiration and respiration, and then in the refrigerator, and you can see based on the absorption rate, you have major differences in the outcome of the test. Now the question becomes, how in the world do you correct for that? You can't graft all the trees that you want to test into pots and let them grow for years until you get leaves, so you've got them in the same environment. That's not going to work. So we tried all kinds of different things to try to correct for the variable transpiration and absorption rate. And remember, I'm doing this at 10 o'clock at night after my kids have gone to sleep. I've tried all kinds of different things, and finally come early June, I've basically given up. I'm like, I cannot figure out how to correct this. And I tell my family, I'm like, I am not going to run any more tests for at least a week. I'm just gonna let the brain reset, see if I can come up with something else, but I'm gonna do anything else for a week. And 2 hours later, I emailed Jared this design right here. And I told Jared, I think that if you change the concentration of the oxalic acid, you're going to get an exponential change in the outcome. And that's what I believe. And the next morning, I was out collecting leaves from a Chinese tree at 3 a.m., ran the test and found out that I was wrong again. It's actually a logarithmic outcome. But when we looked at the logarithmic outcome, we went, we can work with this. This is very consistent for this outcome of this tree. And there's something we can use with this dose response that we can then use to normalize for the changes in absorption and transpiration. And in fact, if I was a toxicologist instead of a lawyer, I would have known that's what the outcome was going to be. Dose response curves are commonly studied in toxicology, and they follow pretty much the exact same outcome that we got when we did the variable rates of the oxalic acid. And what toxicologists look for, amongst other things, is that slope of the linear portion of the logarithmic curve. Because what that slope is telling you is what is the sensitivity of your tissue to your toxin. And so what we figured is that if we could find the linear portion of the dose response curve from our oxalic acid test, that would tell us what the sensitivity of the tree was to oxalic acid. And then obviously, or not obviously, but the lower the slope, the less steep the slope, the less sensitive the tree is to oxalic acid. And then presumably the better it's going to do in the field. So we ran a bunch more tests, and we've determined that the normal trees, the linear portion is between 8 micromole and 16 micromole. And so what we did was we got these 12-volt plates here, and we floated 16 millimeter leaf discs at 8 mm, 12 mm, 14 mm, and 16 mm. And then we calculated the resulting line of best fit through the necrotic rates at each of those points. The slope being the sensitivity score of the tree. So yeah, so there's the first item that you need. And ultimately, at the end of the day, once you get done with all this, these are the items that you need. It's a total investment of like $55. Anybody can do this and run these tests. So there's the leaf disc floated in the 12-well plate. We tape the discs to just a piece of paper, scan it in. This is the worst part by far. This is it's a program called ImageJ. I call this part fiddling in ImageJ. It takes hours in order to get the exact result. Now, when we published this, or when we wrote this for the New York Burr, a computer scientist read this and went, these people are crazy, and wrote a program to do this part of it. It now takes 15 seconds. So it used to take me an hour and a half. So that is quite nice. And then you see for this tree, when you run your line of best fit, you get a slope of 3.26. This was the best tree in Lacine, and you'll see that that was a pretty good score. So then we go back out to the field and run our tests again. So 6.92 was the average quickly dying stump sprout from a Blue Ridge Parkway overlook. Your average Lacine Big trees were 4.5. Average Chinese was 3.5. And then I'd been in contact with the folks at the Ozark-Chinkopin Foundation quite a bit. We ran it with their breeding program, and their average trees in their breeding program was 3.2. Standout trees, all 8 trees that the Ozark-Chinkopin Foundation sent us were very, very strong. And the best trees they had a 2.8 slope score, which was obviously very good for our test when you consider that average Chinese had 3.5 slope score. The Leucine trees were great. And this is not tree 87. I forgot do you remember what the number of this tree is, John?
I think that's 762.
So 762. 762 was right around 4. A very, very strong tree. Tree 87, which I didn't have a picture of, had a 3.2 slope score, which was the first American we'd seen in the Chinese range. And we actually thought at the time that we'd done something wrong in the test, that it had done that well. But as we found out, as we ran more trees, there are many Americans that will score that well. No, I should say many Americans, not that many, but enough to know that it does happen. This is a slide that I really like to show. These are trees from Taylor's Mountain. Obviously, these trees have got some pretty big blight cankers on them, but they've had pretty big blight cankers on them for years. And they still have a full crown. They had a very good slope score. And what I like to point out is that you probably are not going to get to complete resistance breeding Americans, but there's reason to believe that you could have partial resistance. So trees that have cankers but maintain a full crown and aren't dying and it won't die for years, that's an improvement to the genetics for sure. And I think you're seeing that in the Taylor's Mountain trees. Bill Dieter is the president of the Indiana chapter. He has a American orchard that is scored as well as Leucine did. His best tree, which I had a picture of it on one point in time, scored a 2.75, which that tree has been alive for 25 years. It's been horned by deer. And you can go online and you can see Bill Dieter's posts on Facebook about tree row 6, tree 3 has been a very strong tree for years. And oh, here it is. This is that's the best tree in Bill's Beckens orchard. And then Wagner LLC in New York, that tree also scored very, very well. I understand some of its progeny have been alive for many years as well. And it's kind of nice to see an American of that size, just in general. But again, you don't need Americans that are exactly like that. Those ones are really hard to find and basically are 1 in a million. But on the other hand, when you're out in the woods, you do see trees like the Taylor's Mountain trees, and partial resistance is probably useful. So as we're going through this, we run dozens more tests, and we realize average poor trees, the trees that you're going to see that are going to get a rust canker that's going to girdle the tree and kill it in a year, you have a slope score greater than 5. So these are really susceptible. Good trees, which are trees that probably have some dieback in them, but are not dying in a year, are going to have a slope score between 4 and 5. And then the absolute best trees generally had a slope score less than 4. And then this was also very interesting. How many of y'all have heard of the cruddy bark Americans? So lots of people were theorizing online that cruddy bark was some sort of intermediate resistance. We did not see any cruddy bark trees that scored anything better than a 5. It appears to us, at least based on this test, that it is entirely biological. And that the trees you want to find are the trees that are maintaining their full crown and are, the trees that generally look better. So that was kind of an interesting result. And so at this point, we've been putting things out and kind of keeping the online community informed of what we're doing. And we run into the folks at Penn State who want us to do a blind test of their advanced hybrids. And the blind test of the advanced hybrids also came back that the oxalic acid leaf test seems to be working pretty well. So the slope scores under 4, so this is what we would have predicted to be the best trees, have a stem crown index, which is how TACF ranks the trees, had the highest stem crown index. So your best field performing trees have your slope scores less than 4. Slope scores between 4 and 5 had an intermediate stem crown index, and slope scores 5+ generally did very poorly on the stem crown index. So that was very, very cool to see the outcome of the completely blind test on the results. That being said, there were 2 very interesting anomalies of very low slope scores that were from trees that had very poor stem crown indexes. And the first possibility for this, and this is what I believe, is that oxalic acid is not everything. You definitely need additional traits and additional genes in order to have trees that are ultimately blight resistant. So my personal belief is that the test is working and that those trees just are missing whatever else is necessary in order to have blight resistance. The other option is that if I was a toxicologist and I had infinite time to do this and it was my job, I could do a bunch of different points. And you can see here, that's what toxicologists would do. And they would get the whole logarithmic or curves associated. These are not logarithmic curves necessarily, whatever the shape of that curve is. And you can see that a lot of times there is a lag before you get to the linear portion. So that is a possibility, but as a practical matter, you're not going to do that if you're going to be testing these trees at 10 o'clock at night and trying to test a bunch of these trees. So it may be worth somebody going back through and trying to do the full dose response test for some of these anomalous trees, but it's not going to be me. So what's next? Well, we do want to selectively breed the Americans, and what our belief is that this is a pretty good screening test to say, you see an American in the field, it's been alive for a reasonable number of years. You can run it through the leaf assay and then say, you can have a pretty good idea, is this tree alive purely because of biological reasons? Is there hypovirus here? Is there some other biological reason like the cruddy bark situation going on? Or do you have a tree that has a slope score less than 5? That looks like it could be pretty good for further selective breeding. And that's what we want to do. We want to graph the standout performers, and then we want to run the small stem tests in controlled environments for a number of years to ultimately selectively breed the Americans over a period of many decades as make it our next mission in life for the next 30 years to eventually see what happens with this. And when we floated this idea to Cassie and John and Dr. Westbrook sent us this slide, and I'm hoping one of y'all knows something about this slide. I know generally what it's saying is that LSA from Lysine had a 29% survival rate in a small stem test, but I don't know the backstory behind it, and I was wondering if y'all do.
What is the y-axis then?
The y-axis is survival. So there's small stem assays, and you've got the Chinese tree at 97%. The 19% has got to be the typical American. The LSA, and then we've got people standing next to Thompson. I'm going to believe that's got to be a family of Thompson seeds at a 29% survival, which is kind of close to the 33% survival from the best by best, and clearly better than the non-survival. But in any event, what our hope is, and what we're going to hope as we do more of this selective breeding, is that we see these LSA families have survivals that are survival rates that are clearly better than the typical Americans. But I'll kick it back to our folks here to see if they know.
I think that's it, Betty's pointing out that LSAs, if we select for Americans in a certain way, then they can't perform better than Americans.
Yeah, I'm trying to remember the heritability numbers he's, TACF also uses a score basically of 0 to 100, with 0 being a wild-type American with no resistance and 100 being Chinese. And, you know, a lot of the hybrid back crosses are, the threshold for breeding is 40 on that, you know, and some are up 70, 80. And they're, the best LSAs that they've tested with that same protocol get up into the high 20s, and, you know, into the high 20s, maybe just below 30, and shows less heritability than is shown in the hybrid population. Brett, I don't know, you might know better numbers than me. Is that heritability in the LSAs, or that Jared has
I
got?
don't know the heritability, I just know it's terrible.
Yeah, so it's been established it's heritable, so yeah, so that's obviously a good thing, otherwise you're wasting your time.
Exactly.
I think we did that in 1980,
Yeah,
Mhm.
yeah.
so.
So then, you know, shout outs to all the people that helped. Obviously, it wasn't just me and an optometrist in order to pull off something of this size. You need a lot of people to help you do this, including John was extremely helpful in showing us around the scene and helping us. You know, my initial tree pruner was not ultimately turned out to be not very useful. And all the folks on here were very, very good to us. And what we are looking for folks to do now in particular, hopefully we're going to be growing out a lot of these families over time. Right now, there are not very many families to be grown out. But we do want folks to be out looking for trees, Taylor's Mountain type trees, any type trees that look like they may have some partial resistance. And then email us and we can go get some leaf assays and we can go try it out and see if we can get some grafted orchards together and get some more nuts and start growing out more families. Yes.
Can you speak a little bit to the repeatability of the test? And I'm sure you've taken the same tree and done it a month later, a month later, a month later. Does the age of the leaf, does time of year, does any of that matter?
Yes. So so you're going to get totally random results until sometime in June.
Okay.
You need to have, what we wound up doing this on is on sun hardened leaves. And so sometime in June in Virginia, the leaves have basically stopped growing. And at that point, you get pretty consistent results. So we tested 783 in Thompson and Ragged Mountain 3 times after that point, and the results were all within 0.3.
Wow. Wow. That's impressive for a biological test, even in itself.
And
does did the Shinkapin Foundation, are they taking over some of your ideas?
Oh,
like multiple molar
yeah, they've
concentrations?
totally switched. I went and spoke to them at their national conference, and they've switched to the multiple concentration. Any other questions? Anybody know any good trees that I need to go test? That sounds good. All right. Well, thanks a lot for having me, guys.
Actually, I mentioned one this morning that's on top of Sharp Top. So get your friend from Bedford to hike Sharp Top sometime in June.
Perfect. That sounds good.
It's at the very peak, and it's just outside the window of the stone shelter there.
Perfect. That Shark Top Mountain?
Sharp
Yeah.
Top, yeah, and at Peaks of Otter.
Okay, perfect. That sounds good.
Is the video working, Jack, or is it just being freezing? You're muted. You're muted.
Yeah, it was just working until you switched or something. But I saw his whole presentation and saw him.
All right, well then I'll just leave it on then. This is you, Fred. Can you see Fred's presentation?
Yes.
Cool. I'm glad you can too.
All right. And then,
We have Dr. Fred Hubbard coming up next to talk about our efforts with our in Northern Virginia, we have 3 large chestnut seed orchards, and Fred will explain why they're there and how they're coming along.
And you just click these arrows, Fred. Or do you want me to do it for you?
Uh-oh. That's big.